Introduction to Vectors. Now there's probably a little bit of information that you need to be told here. So vector really has to specify direction and length. So 4 kilometers northeast is a good example of a vector because it specifies a direction and a length. Directed line segments, a quantity that has direction as well as a magnitude. We can use an arrow to represent it. Just like this. So this is vector A to B. Okay, it's also a directed line segment from the point A to point B, but we are going to talk to that about as vectors. Okay, so it has an arrow and a length. Column vectors. Yeah, look, as you can see, it's just a matrix. Okay, that's all it is. You can start anywhere to actually illustrate this. So even if you start here, you're going 3 units, always the top one is the X part, so 3 units across, 2 units up, and you end there. So that A, B line in red is the vector A to B. Vector notation, okay, we can use single letters, bold and lowercase to classify a vector, for example V, or we can use that A, B with the line on top. Example 1, it says draw a directed line segment corresponding to 3, -2. So I'll quickly draw my axis. I probably should have had my axis already drawn here. There it is there. Y, X, doesn't matter where you start. I'm just going to put some units in here. 3, 1, 2, -1, -2. I'll mark my 0 in there. Right, I'm going to start here. I'll start up here. There we go there. That's my A point. If I need to go down 2, because -2, and across 3. So it doesn't matter which one you do first. Better put another one in there. I need 4. So 1, 2, 3 across and down 2. 1, 2. So I'm going to end up right there. That's my B, and if I can draw a straight line from there to there, me and my straight lines, and put an arrow, that's my vector 3, -2. The vector U is defined by the directed line segment from 2 to 6, 2, 6 to 3, 1. If U equals AB, find A and B. So really, if we draw from the point 2, 6 to the point 3, 1, that's what we want to find. So really, it's the change in the X values and the change in the Y. That's what's going to give it to us, isn't it? So rise over run. So therefore, I can just work out U will equal 3 minus 2 and 1 minus 6. Now remember, for this, it's always X and Y. Okay? X up the top, Y down the bottom. So even though I said rise over run, it's X and Y at the top, which means 3 minus 2 is 1, 1 minus 6 is -5. So that's what's happening from there to there. It goes down -5 and across 1. Oops, I forgot to write A equals 1 and B equals -5, but you can see that I found it there. Addition of vectors. Now, we've got 2 vectors, one from here to here and one from here to here, and we add them up, we get that resultant, so this final vector from there. And we can represent it like that. If we want to go the opposite way, it's just a negative. Okay, so these are just a couple of examples. Adding column vectors. Adding column vectors, just like matrices, we add them together. So we add the 2 top numbers, that becomes 3, and the 2 bottom numbers, that becomes 4. And you can do that again on the same thing, on the diagram. Scalar, that's just multiplying a vector by a number. So if the vector is 2, U, then 2U's twice as it. If it's U, half U's a half of it. If I was to multiply, if that's my U and I want to times this by 2, so 2U would be 3 times 2, which is my 6, and 2 times 2, which is my 4. I want to multiply this. If it's negative, they change the sign. You can see they've changed the sign, negative there and negative there. If it's -2u, we times it by the -2, so it becomes -6, and that becomes -4. Okay? If it's just negative by itself, it changes direction as well. So instead of going from A to B, we're going from B to A. Okay, that's all it does. Zero vector is one that has 0 length. Okay, subtraction of vectors. Okay, so it says to find u minus v, we add the negative v to u. So if there's my u, there's my v. U minus v is that way. There's my u. V normally goes this way, but we want it to go the opposite way because of the minus, so that gives me my u minus v. Example 3. For the vectors u and v, find 2u plus 3v. So 2u plus 3v will equal. Now I'll write the whole thing, but it's 2 times the u1, so actually I won't, which is 6 and -2, plus 3 times the v1, which is -6 and 3 2s are 6. Add them together. 6 and minus 6 is 0. Minus 2 plus 6 gives me 4. So it's 0, 4. Polygons of vectors. For two vectors A, B, and B, C, we have. So A to B and then B to C gives us the result of A to C. And A to B, then B to C, C to D, D to E, F to E gives us 0 because we're back to the start. F to A gives us 0 because we're back to the starting point. Example 4, it says illustrate the vector sum AB plus BC plus CD, where A, B, C, and D are points in the plane. Okay, well, illustrate means draw, so we got to draw it. So, and remember, it's going to end up to being A to D. So this A to D is going to end up happening down here somewhere. There's going to be my D, and that's going to be the final result, A to D. So B to C, I'll just draw out here. There's C. And then C to D is going to be this final one. Oops, supposed to be a straight line. Final one down here. So AB goes there, BC goes there, CD goes there, and then the final result is A to D. So we've just illustrated that one. Parallel vectors. Now, two parallel vectors, of course, have to have the same direction or opposite direction. Two non-zero vectors, u and v, are parallel if there is some k involved that is constant. For example, these two are parallel. This is just 3 times that. Times this by 3 and I get the same thing. Position vectors. We can use a point 0, the origin, as the starting point for a vector to indicate the position of a point A in space relative to 0. Okay, and we call that position vector 0 to A. Linear combinations of non-parallel vectors. If two non-zero vectors, A and B, because if they're 0 then there's no point, are non-parallel, then M plus A, MA plus MB is PA plus QB, implies M equals Q and M equals P and N equals Q. You'll get an example of that as we do it. Okay, it's not that hard. Example 5. Let A, B, and C be the vertices of a triangle and D be the midpoint of BC. Let A to B, so that's that way, A to B, and that's A, and B to C, I'll put it in the middle, be B. For each of the following, find each of the following in terms of A and B. So part A, B to D. B to D, well, that's just a half of BC. That's a half of B to C. And B to C is B, so that's a half of B. There's the first one. B. D to C. D to C is the same thing. That's just a half of BC. We just already worked that out. That's just a half of B as well. C. A to C. A to C. A to C will be A to B plus B to C. A to B we know is A, B to C we know is B, so A to C is A plus B. D. D is A to D. A to D is A to B, and then from B we have to go to D. A to B we know is A, B to D we worked out before, that's a half of B. So there's that one. And E, C to A. C to A. C to A, we've got to go from C to B, and then from B to A. Okay, now C to B, that's the opposite of B to C. So it's going to be negative B. Okay, negative B. And B to A is the opposite of what we're going from A to B. So that's going to be minus A. Take out the negative, and I've got A plus B. So there's that one there. Example 6. In figure DC equals K to P. Equals KP. D to C. Just let me write that in. D to C, that's going to be KP. K, of course, cannot be 0. Part A, express P in terms of K, Q, and R. There's my P there. In terms of K, which is that one, Q, and R. Okay, so P is equal to A to B. And A to B equals A to D plus D to C plus C to B. A to D, I know that's Q. D to C, they give it to us, it's K, P. And C to B is minus R, because it's got to go minus. Now I want P by itself, so that means I'm going to go P minus KP. I'll write all the steps here, equals K minus Q. So P1 minus K equals K minus R. I'll leave it like that because I've got P by itself just by dividing, won't really matter. B, express FE. F to E is that line there. I'll do it in red. In terms of K, P, which is that P up there, and to show that FE is parallel to DC. Okay, so I'm going to do it like this. F to E is the same as going from F to D, and then going from D to C, and then from C to E. I'm going to use that line. You can do it the other way and going all the way around. It doesn't really matter. So this is minus Q. D to C we know is KP. And C to E we know is R. Now look at this. I've got Q minus R here from 1, and I've got R minus Q, so the negative part of it. So I'm going to say, but R minus Q will equal negative P1 minus K. That's from part A. So therefore F to E will equal KP minus P1 minus Q, which will equal P K minus 1, but plus the other K, because remember, when I work that out, it becomes plus, and therefore I've got P 2K minus 1. And we know that that's just parallel to DC, because DC had the KP. That's just another multiplying it. C. If FE equals 4AB, find the value of K. F equals 4AB. Well, we know AB is P. So FE will equal 4P. I know what FE is. There it is. We just worked it out. So let me substitute it in. So I've got negative P 2K minus 1. Well, the P's will cancel. Oh, that's not a negative P, sorry. P's will cancel. So we've got 2K minus 1 equals 4. 2K equals 5. K equals 5 on 2.